this video we're gonna talk about derivatives part 3, which is about quotient rule. So whenever I'm talking about quotient rule, we should have a quotient, which is a fraction basically. So let's say I have a function that has the form f over g. So something in terms of x divided by something in terms of x. Then to find the derivative, which is dy over dx, or we can call it y prime, then you have to apply this rule, f prime g, so f prime times g minus now g prime multiplied by f over g squared. So we just apply this rule. Let's check some examples. So if y is equal to 3x cubed minus 2x plus 5 over x squared plus 1. To find dy over dx, I need to apply the rule. So the one on top is the f, the one down is the g. So I apply the rule. What is f prime? In this case, the derivative of the numerator. So we bring the 3 down, we multiply it with the 3, we get 9, x exponent 2. Derivative of 2x is just 2. So the minus is minus, and the derivative of 2x is 2. The derivative of 5 is 0, so we don't write it. So this is f prime multiplied by g, which is x squared plus 1. Minus, now we need to do g prime. Derivative of the denominator, we bring the 2 down, it becomes 2, x exponent 2 minus 1, which is x exponent 1. The derivative of 1 is 0, we don't write it. So this is the g prime is only 2x multiplied by f. Over the g, all of it squared. The one down, we never expand. So no need to expand it, because maybe later on in some functions where you find the derivative and you can simplify with the denominator. So it's better to keep it as product of factors or just a factor exponent 2. Now let's simplify the numerator. We need to distribute, so this over this, we get, I'll write it down, 9x exponent 4 plus 9x squared. Then we distribute the negative 2. It becomes minus 2x squared minus 2. I'm done with the first part. Now the trick is, or the idea in the second part, where most of the students, they forget the minus sign. They do it for the first term, but they forget to distribute the minus for the other one. So in this case, whenever you have quotient rule and you have two factors multiplied by each other here, keep the big parentheses, distribute the 2x, and after that distribute the minus sign. So 2 times 3 will be 6, x times x cubed will be x exponent 4, then 2x times negative 2x will be negative 4x squared, then 2x times 5 will be plus 10x. The one down, it stays the same as I said, and we continue. I will write 9x exponent 4. Now if you notice anything that you can simplify, do it. So 9x squared minus 2x squared will be plus 7x squared. These are similar terms. The minus 2 stays, and then we need to swap the signs inside. So distribute the minus, so it becomes minus 6x exponent 4, then plus 4x squared, because minus times minus will be plus, or if you want to think about it, the minus outside here will flip the signs inside. So the 6, it will change to minus 6, the minus 4 will change to plus 4, the positive 10 will change now to negative 10x. Now I look at the numerator. If anything to simplify, we will do it. I can notice that we have 9x exponent 4 and negative 6x exponent 4. So 9 minus 6 will be 3, x exponent 4. Then the x squared together, so I take this with this. Plus 7 plus 4 will be plus 11, x exponent 2. Then I have one term with x and one term which is constant number. Let's write in descending order of x, or descending exponent of x. So minus 10x first, and then the constant number at the end. If you write in any order on top, nothing will change, because addition and subtraction here, we can swap the terms and nothing will change. And basically this is our final answer. Just as a note, you're not allowed to simplify anything on top with anything in the denominator. Why? Because we have addition and subtraction. Because some students, they tend to do this. So we will never do that as long as we have addition and subtraction. Only you can simplify if you have multiplication in the numerator and multiplication in the denominator. In that case, if you have x squared and x squared, you can simplify. Let's look at another example. Maybe I'll make this one harder. So let's say I have on top radical x, and we spoke about radical x in the previous video, and down I'm gonna write x exponent 2. Now, to find the derivative of this, I'm gonna consider the one on top to be f, the one down to be g. So to find dy over dx, I need to do f prime g minus g prime f, so this is the rule, over g squared. So I follow. F prime, in this case, derivative of radical x, as I spoke in the previous video, is just 1 over 2 radical x times g, which is x squared, minus g prime, the derivative of g is just 2x, times f, which is radical x, over g squared, which is x squared, squared, equals. For the first one, you're gonna multiply the one with the x squared, so you get x squared over 2 radical x minus 2x radical x over x exponent 4, because you do times instead of parentheses, so 2 times 2 will be 4. Now I want to simplify this question more, or this answer more. I can note that in the numerator we have fraction minus another term. So 100% we can write this term over 1. So we can write the 2x radical x over 1. Now, to subtract two fractions now, we need to have the same denominator. So I check what do I have in the other denominator. It's 2 radical x, so I multiply down by 2 radical x, and in the numerator by 2 radical x. Now I continue, and I will get x squared over 2 radical x for the first one, minus 2 multiplied with the 2 will give you 4. So you write 4. X is just x, and as I said before in the previous video, radical x multiplied by radical x will give you radical x squared. The square with the radical can cancel, so you can just get x over the same denominator, 2 radical x, and the whole thing over x exponent 4 equals, you will get x squared minus 4x squared now, because x times x is x squared, over 2 radical x over x exponent 4. Now, here there are two ways to proceed. The first way is, whenever you have a fraction, a over b over c like this, you are allowed to take the b next to the c and you write a over b times c, like this. So basically here we have the fraction on top, a over b, and c is the x exponent 4. You are allowed to take this down. So this is the fast way. X squared minus 4x squared, as if you are doing 1 minus 4, so it becomes negative 3x squared, over 2 radical x times x exponent 4. I will write it as 2 times x exponent 4 times radical x. For sure we can write that, because if you have this, multiplication is commutative, so you can swap the places and nothing will change. As you can notice, what do we have? X squared on top, because everything here is just multiplication. We can cancel x squared on top with 2 from the 4, it becomes 2. So I get minus 3 over 2x squared radical x. Now if I don't need to keep the radical in the denominator, so we have to rationalize. In this case, I need to do more steps. I will rewrite it here. So if I have radical x and I want to rationalize, I want to remove the radical, so I should multiply the radical x by itself. But if I do it down, I should do it in the numerator. Equals, on top you get minus 3 radical x now, over this with this will give you x. So x squared now multiplied with the x will give you x cubed, and this is the simplest form you might get.